हरिः कर्ता।
Now let's apply this cross tabulation concept to the some of the real world data sets and explore the patterns or insights between the categorical variables of a real world data set. Let's get into the action. So first let me begin with players data, and here is our player data. Okay, so let me make a cross tabulation for this. So let me first bring up the columns. What all columns we have? This is also part of exploratory data analysis. So whatever we are doing. So far, let me explain here. So far, we have learned in statistics. One is introduction to statistics. Here we have learned about variables and sample population and levels of measurement and data types. So this is also part of exploratory data analysis. Then we move to descriptive statistics. So here we have learned about various technologies, various concepts from beginning with organizing the data, then summarizing the data, then additional information. So out of that, in summarizing the data, we are doing measures of association. So we have seen correlation, covariance, scatter plot in measures of association. Now we want to find out the associations between the categorical variables. Now we are looking into your cross tabulation. So this everything comes under exploratory data analysis. This is very important step for a data scientist, exploratory data analysis, and this is the first step of data science project. Anyway, let's get back to our work. So players dot columns, this is an attribute, columns is an attribute, and you got the second name, first name, gender, height, and weight. So first I want to explore the relation between a gender and height. I just want to see, is there any specific relation between a gender and a specific association between a gender and height? So for me, the question is height dependent on, for me, the question comes like this, is the height of the player is the height of the player is the height of the player is associated with the gender of the player, so that's what the question. We need to answer this question because both gender and height are okay. So that's what I want to see first, but before that I need to convert this height in centimeters as a categorical variable. So let me convert that and then explore. Yep, let's convert this into categorical variable. So let me bring it up, the height in centimeters, players height in centimeter. So I just want to check the unique values first. Unique Oh, from 170 centimeter till 219, it's going till here. Okay, let me convert this into categories. Let me make it into the bin labels. First, I'll say height bins, sequence. That's, I'll start with 170 to 185, then 185 to 200, and 200 till 219. Okay, so now I need to label them. So my labels, so here, so first label would be normal height, and normal height, and then excessive height, and then over height. So this is how I want to label this. So my height labels are ready. So now let me add this. So players, so height labels, sorry, height categories, and height categories is equal to pd dot cut. This is the method I am going to use. And then as usual, players, so this is height in centimeters, and this I want to label it. So for me, bins is equal to height bins, then I got the labels is equal to height labels. Now let's look into the players and see what's gonna happen here. Yes, of course, we have one nan, so I think that's more than, you got till 219. Okay, that's not available values. So in that case, what we can do, drop NA. Okay, let me take players 1 is equal to, and players, yes, now you see that you got all normal height, and excessive height, and then over height. Okay, so now let's look into the relation between, association between the height and gender of the player. Height and gender of the player. Let's see what result we are gonna get. Pretty simple. Let's say cross tab H and G, height and gender. So PD dot cross tab, and players 1. For me, the first one, I want to check the gender is dependent. So is the gender dependent, sorry, is the height dependent on gender? That's what I want to see. No, so I want to see whether gender and other one is players 1 is height is dependent on each other. Height category, sorry, let me directly copy from here. Sometimes, and execute. So let's print the cross tab HG, and here is that. So if you see that a male, Okay. It's clear cut. So the male has excessive height and the over height. When it comes to women, the 0 over height and 30 excessive height, but the normal height is 319. So woman is uh, most of the women will have normal height, whereas the men is having the excessive height and then over height. So men, there is a clear cut association or the relation between the gender and the height of the player. So that's what this data is saying. Now let's try to explore gender and weight. Let's try to find out that is there any specific relation between the gender and weights. But before that, I need to. So now let's try to explore the association between the weight and the gender of the player. Let's see what's going to happen. Is the weight of the player is associated with the gender of the player? Not sure. Let's explore. Yep. So for that, I need to bring up the weight for me first. So players one, sorry, weight in kg, and then go for the unique. Okay, starts at okay, 64, 78, 99. I just want to have the sort out. So what I can do here is, let me put so this as weight is equal to, so now weight and sort values. Okay, so this is what the weight is, and so you got the unique values. Let me print. So it begins at 99 135. So let me find out the max. And also let me find out the min. 218 and print both. Yeah, so maximum is 218, minimum is 45. So based on that, I have to make my labels. Let me copy this from here and put it here so that I can make labels. So I'll say weight bins and weight labels. So let me begin with 45 and 45 to underweight. Let's take 45 to 60. This is underweight. The first section is underweight. I can't say, of course it depends upon the height also, but still that's fine. And till 80 90, I'll put it as normal weight. Then 90 to 150, this is overweight. The final one is obese. This is 218. So that's it, and let me convert this into players 1. Weight categories. Weight categories and cut players 1. Let me check players 1. Weight in kg, and bins, I'll go with the weight bins, and labels, I'll go with the weight labels. What's the issue here? Players 1. Okay, that's fine. So 1, 2, 3, 4, 45 to 60, 60 to 90, 90 to 1, 60 to 90, 90 to 150, and 150 to 218. And let's ask for players 1. And here is your data. So other than one nan, rest all were so categorized. Now it's time for us to find out the relation. Let me go for the cross tab, weight and gender. So player 1, I'll go for the gender, and player 2, I'll go for the weight categories. Let me copy this from here. Sorry. Yes, that's it. Okay. With this we can say that women are not overweight nor obese. The women players are not overweight nor obese. So some information we can take, some inferences we can take from here are, women are more healthier than compared to the men. So they maintain their weight. So some are underweight, but only 20 men were underweight, whereas the women 65 were underweight. But when it comes to normal weight, 274. So most of the women are maintaining their normal weight. So they are much healthier than the men. But when you see the men players are literally going in the bracket of overweight and obese. So that's what the inferences that we can make out using cross tabs. Okay. Now, let's also look into the gender and then country. So, in which country has highest number of women players? Let's look into the gender versus country. Gender versus country. So, see, let me copy from there. Team, it's team only. Yes, this is a huge data, but you can see each and every. Okay. Highest one, Olympic team 23, and Canada has men high, and most of the countries are coming up with the high men and very less women. Let me scroll down. I'll try to find out the higher women. Yeah, here it is. Some team GB, team USA again. Women, men are high, women are less. So it clearly tells. Oh, Uzbekistan, Uruguay, everything is like it's men are dominating in soccer. That's what it says. So now let's get into the another type of data. So customer shopping, customer segmentation related data. I'll say cust and pandas dot read CSV and customer shopping data. So this is what the cust data. I don't think you'll find any. Yep. You got the shopping mall, invoice data, payment method, price, quantity, category, age, gender, customer ID, and invoice number. So first I want to see is the gender and a category of buying. Is there any relation between the gender and category? It's exploring. Is gender anyway influencing the category of purchase? So let me check the cross tabulation and paste it here. So this is your category, and this is cust, and this one is gender. This one is category, and here I'm gonna put it cat G, and that's what it says. So books, female, okay, female buying books, and clothing, female is dominated. Magical. These are actually real world data. So that's the reason you can see 20,652 female, and then male 13,000, and cosmetics again female, food and beverage again female, shoes again female, souvenir female. Oh, whoa, everywhere, everywhere, clear cut domination, but only where no, there is some kind of balance is technology. So female is 2,981 and male is 2015. So this or else toys also. But here almost 7,000 difference for the clothing. Clothing it's 7,000 difference. Of course, we know that the female like to buy clothes a lot, and cosmetics at 3,000 difference. That means men is also buckling up, and men is also taking more cosmetics now these days. So food and beverage, there is clear cut domination, but one thing we can say clothing. So this is what this is the customer behavior based on the gender. So basically, female is going for uh, the more number of female customers are going for the clothing and cosmetics than compared to the male customers. So now we have to devise our marketing strategies and advertisements, keeping the female also in mind so that we can attract them more and the purchase can be increased. You can give more offers to the female, and that's marketing team will the expert subject matter expert will decide what strategies they can do take, but as per our work is to give them the patterns. Okay, and next one. So is the gender, quantity, of course, but that's fine. Price, let's check the gender and quantity, how it behaves. I'm not sure whether it works out, but just want to see how it behaves. That's it. So gender versus quantity. Okay, okay. Clear cut domination of female. Clear cut domination of female. This is okay. One everywhere. Maybe this data set itself consists of number of females, but however it may be, this is the real world data. This is the real data from one no, shopping mall. Okay. So now one more thing I just want to check is, I just want to check whether is there any association between age with the payment method. Okay, so for that, let me convert that age into categorical variable. Let me check somewhere I have converted before. This is height bins. Let me take the age bins directly. Okay, let me copy this. And I'm gonna take the age bins. Now what I want to check here is there any association between, is there any specific association between our age of the customer and the payment method he's or she's using? That's what I want to see. That's okay. Let me mark age bins here. But before that, let me check. So, cust. So 28, and then I'll go for the unique. So in addition to that, I'm gonna see, let me do few more things simple. Let me cust age this describe, and here is what complete information. So mean, standard deviation. So these are not our point of interest for now, because we have seen them in measures of where measures of variability, measures of central tendency, measures of this is count and all comes under the organizing data distribution. And you got the mean minimum. So this is minimum age is 18, and then maximum age is 69, and 25 percentage, that's the quartile 1, quartile 2, and quartile 3. So 30, 43, 56, and maximum is 69. So based on that, I'm gonna make it. Okay, so let me say age bins. Let's begin with 30. So 30, I'll say young adults. Then 32, I'll go till 45, because 45, then 45 to 69. That's enough. 30 to 45, I'll say middle-aged adults and older adults. Middle-aged adults, and 45 to 55 would be our older adults and seniors. And final one, I'll go for the seniors, 55 to 69. And let me say this as age categories. Let me add this, and this is cust and cut place. Let me put the age, let me put the cust here, and this one is age. This is what we want to convert. And bins is age bins, and then labels is age labels. Okay, there was some issue. Bin labels must be one. Okay, what's the issue here? So one, and okay, middle aged older adults and seniors, middle, and 45 to 50 older adults, and 69 is seniors. But what I used, okay, sorry, that's my mistake. Sorry. Age labels. Yep, done. Now let's see cust, and here is that age categories, there are some nans. I think let me put sorry, just a minute. Where is this data? Okay, still there is let me drop the cust one is equals to cust dot drop na. I don't want this. So now let me print cust one. Whatever we are doing, this is all exploratory data analysis. This is part of okay. So now we got now age categories. Now what I want to check here is there any association between the age and then payment method? Let's get into the work. So age and payment method. So PD cross tab cust one. Let me go for the age, and here I'm gonna give the payment method. So A and then P, and here is that the information. So cash, okay, okay. So I used the wrong one. Age category, sorry. Yes, here is that. Now my seniors are overwhelmingly going for the cash. Okay, even the middle adults also going for the cash, and older adults also going for the cash. And this data is from the not from the Indian shopping mall, because if it is Indian shopping mall, now most of the people will go for the UPI or Phone Pay or Google Pay or anything else, because that's the financial fintech development in India. That's the that kind of advanced level technology we are using, whereas United States of America, Europe, and any other countries falls behind us. They're far away from fintech technology in India. So that's the reason this data is still there, 10 years behind India. So they're still doing the cash transactions, credit card, debit card. But however, you can clearly say that you can't say anything. The age is not particularly dependent on which payment method they are using for this shopping mall. For this shopping mall, if it is India, you might have some amount of relation, because in India most of the young people will be using the mobile phones, and so that's the reason they would be doing the phone pay or this thing. When it comes to the older people who crosses 60, they might not have the understanding about the technology. They'll still go for the cash. But things have changed. Even the smallest of the smallest shop or in villages also, they are using the phone pay. They're just putting the scanner. You can just pay through the phone pay. That's the level of fintech development happened in India. And whereas India is almost 20 years ahead of any other country. It could be US or Europe. Proud to be a Bharatian. So that's how you can leverage the cross tabulation to understand the association and the relation between the categorical variables. I hope you will explore more with the different types of